Hello, wonderful physics students. Today we are going to be talking about momentum. Hopefully you all have watched the introductory video, the physics and car crashes. And it introduces some of these terms that we're going to be talking about, but we're going to go into a little bit more depth. And I'm just going to make sure you understand how to calculate momentum and what the basic units are, things like that. So momentum. Many of you have heard momentum probably like in a sports context. Probably some of you have heard it in a physics context as well. But in sports, momentum is often described as, you know, this team has a lot of momentum going into the finals, right? And it really describes a team that has a lot of energy. They've been playing well. They're doing really well. They're hard to stop, right? And that the same is true in a physics context as well. That an object with a lot of momentum is going to be more difficult to stop than an object with less momentum. And so momentum is kind of a hard term to describe versus something like speed, where we're talking about distance divided by time. It's a rate of change. Momentum is a little bit wishy-washy that way. But I often like to describe momentum as mass in motion. So it's a description of mass in motion. So our formula for momentum, the symbol for momentum is actually P. Why P? Well, what's M already taken by? Mass, right? So we have to use a different letter. And I think a physics student told me this once, and I'm sure I looked it up at some point, but I forget off the top of my head. It has to do with another language or something like that. They decided to use P. So P stands for momentum. And the formula is M times V. Remember, mass, or M stands for mass, and velocity, or V, stands for velocity, right? So the formula for momentum is pretty straightforward. You take the mass of an object in kilograms and multiply it by the velocity of the object in meters per second. And that's how we calculate momentum. Pretty straightforward, nothing too crazy there. Our units of momentum, well, if momentum is mass times velocity, well, what are our units? We just said of mass are kilograms. And multiplied by the units of velocity, meters per second. And so our units are going to be kilograms, meters per second. Awesome. So this is the units of momentum. Kind of a weird unit, but that's what it is. It's not like a Newton where it's one nice svelte unit. It's kilogram meters per second. So when you write any answer to momentum on a quiz, homework, it's going to be kilogram meters per second. All right. Do we think momentum is a scalar or a vector? Well, momentum has velocity in it, and we know that velocity is a vector. And so if velocity has a direction, and velocity is in the momentum equation, our momentum should have a direction as well. And so momentum is a vector. Direction does matter. So it's a vector. And the last question before we end this video, pretty short video today, is how can we get momentum to change? Well, there's two ways. Momentum is comprised of mass and velocity. So if either the mass changes or the velocity changes, our momentum will change. So we can either change our mass or change our velocity. And remember, the triangles is the symbol delta, and that just means change. thank you all for watching. In the next video, we're going to go a little bit deeper into what causes a momentum change. How do we get an object to change its momentum, and what do we do to it to get it to change? Thank you all for watching. I hope this was informative. We'll see you in the next video.